What is the slope? 3. How did you know it was 3? Shh. Go. Yeah. That's right. If x plus b, the slope is 3. This is nice and easy because what kind of graph is this going to be if we graph it? It's going to be a line. And all lines have the same slope, right? Why if I did this? Yes, I am. Thank you. Thank you for the reminder. If I did this, crikey, it's going to be a bad week. Okay. If I did that, what's our slope now? Is it? What kind of shape is that? Oh, we've done this. X squared renders us what kind of shape? Oh, yeah. It's a parabola shifted down 7 and made narrower. So is our slope always the same now? No, it's not. No, it's not. You cannot, the only kind of function that you can just look at and say, boom, that's the slope all the time, is a line. Well, it's not like other graphs don't have slopes. They're just changing all the time. If we were to actually look at this, for instance, this is approximately what that would look like. Now, if we took, when it comes to curved surfaces, you have to take an instantaneous slope, right? Because since it's ever changing, you just need to look at a slope at a given point. The slope at this given point would be a big negative number. The slope at this positive point, or at this point, would be a big positive number. It's ever changing. Well, how do you calculate the slope? I'll give you a hint. You did it as a DOM last week. Remember? Yeah. y2 minus y1 over x2 minus x1. You need 2 points, dose, to calculate slope. y2 minus y1 over x2 minus x1. Okay? Now, if you need 2 points to calculate slope, let's look at that exact same problem we were just doing. 3x squared minus 7. Okay? And then here's a bigger drawing of it. Let's say I wanted this slope right there. Okay? What would give me the more accurate slope? If I took this point and this point to calculate the slope of this, was that going to be accurate at all? This slope is like this. This slope would be like this if you drew it through those 2 points. Is that accurate? No. What if I took this point and this point? That's still not accurate, but it's closer, isn't it? What do you think we could do to get the most accurate slope possible? What 2 points do you think we need to choose to get as close a slope as possible to that instantaneous slope? I'm not saying give me numbers, but give me a theory. What? Exactly. We need 2 points that are as close as humanly possible to that point. Now, let's think about this for a second. Let's say I took the points, let's say this is x equals -1, okay? Now I want 2 points really, really close together. So I'm going to use that one and x equals 0, okay? Those are my x values, which apparently I have to write up here. So if I was plugging those into my slope formula, that would be -1 and 0. Doesn't really matter what order we do it in as long as we're consistent. How am I going to get the y value? How do I get y values when I'm given a function? Yeah, just plug them in, right? In function notation, isn't this exact same thing right here? Isn't that the exact same thing as f of x2 minus f of x1? Meaning, for this y value, you plug in the x2, and for this y value, you plug in x1 into our function, right? Yes. Okay. Well, this is going to be, if we substitute this out for this, that's going to be the formula we're dealing with today and tomorrow. Function over x values. Just remember that these are nothing more than y values. Okay? Now, what is this number? Let's say we had chosen 3 and 7 as our x values, or 2 and 9. Okay? The bottom is always going to equal the difference in those two numbers. Would you agree with that? Let's call that arbitrary distance. Let's make our own formula. Let's call this distance h. And h will just permanently stand for the difference between our two x values. Okay? Difference between our two x values. Well, So on this one, what would our h value be? 4. On this one, what would our h value be? On this one, what would our h value be? 1. Yeah, we're just looking for the distance between these 2 points. Any questions about where we're getting the h value? Just the distance between the 2 x values we're choosing. Okay? Now, by that same rationale, if this h just equals the distance between these 2 points, couldn't I also label it, let me get myself a little bit more space here. Couldn't I also label it like this? If we have one of our x values, let's call it f of x, couldn't I just call the other x value f of x plus h? Let's think about that. What about this one? The first one was 3. We said our h value was 4, so wouldn't that be f of 3 plus 4? And that's right, isn't it? 7. Or if I said our second example, f of 2, what did we say our h value was for this function? 7. So wouldn't this just be f of 2 plus 7? Raise your hand if what I'm saying right now is you're like, what exactly, where are you getting that h value? Yes, I'm about to talk about that. What we're doing is we're writing a generalized formula for slope. Okay, h is the distance between them, and by what we just talked about, let's see, that is the same exact slope formula as right here, but this. We have said that we're just going to call h the difference between the x values. And what we were showing over here with the 2 plus 7 and the 3 plus 6 kind of thing, or 3 plus 4, was that basically in the top, that's going to be our first y value, and then our second y value, which is nothing more than the first one plus whatever that distance was. It doesn't really matter, but yes. Yeah. I did. Sure. Questions about where I got this? Well, if we're looking, who was it that said we wanted 2 points really, really close together? Is that you, Austin? If we want 2 points that are really, really close together, we want h to be as close to 0 as possible, don't we? Because the closer this number is to 0 without actually being 0, then the closer our values are going to be together and give us as close a slope as possible. That is where these limits are going to come into play. This is our formula for the day. Hey, touche, you were right. Come first. Nice. Only difference is, instead of x, they're using a. This is 11.4. This is 11.4, and that's the formula for the day. That's the last formula I'm going to give you this year. That'll be on your final. And it'll be on your test on Thursday. Over all the stuff we've been covering, sequences, series, limits, and this stuff. Only difference between that formula and the one we just wrote is that they're using x instead of, or excuse me, a instead of x. That's fine, sure. I think it's easier as x. I always do it like that. The only reason they do that is because we're going to end up in just a minute, we're going to be plugging things into that formula and substituting. And since, most functions, they give them to you as x, they like for you to be able to keep track of, this is what I'm doing, this is what we started with different variables. I think it's easier to use that. F prime of A. F prime of A. That's what that little tick mark is called. It's called prime. That's going to give us the derivative. This is the derivative function of f of A. Every function f of x has a derivative f prime of x. Here's what this function is going to do. After we have found what f prime of x is, its sole purpose for existence is to tell us what the slope is for the other one. So, back to this example. Has everybody got this written down? Okay, well I can remember it. Our original example was 3x squared minus 7. Okay? Well, when we're done here, I believe we're going to find out that our f prime of x function is 6x. Here's the point of this. If I said, what is the instantaneous slope of this guy at x equals 2? So if you were to draw it, at this point, what's the instantaneous slope? At x equals 2. You just plug that into the derivative function. And if you plug 2 into the derivative function, what would be our slope? 12. What if I said at x of negative 3? What's our slope then? Negative 18. So we're going to be finding this slope function, called the derivative, but it's really just a slope function. So here we go. 2 parts, which I believe they have backwards. The first part is actually part B. We're going to find f prime of x. Find the slope-intercept equation of the tangent line to the graph. Well, the tangent line, who knows the definition of a tangent line? Yeah. Exactly. It touches at exactly one spot. And it's the perfect equation for a slope formula, right? Because it's going to touch that exact one spot, meaning that it's at that instantaneous spot exactly parallel. So, finding the equation of the tangent line is finding the equation for the slope formula. So, we're going to do part B first, and then we're going to plug these points in to find out what the exact slope at that point would be. But first, part B. We don't even need these points over here yet. Here we go. Number 1. We're going to plug that formula to find f prime of x into f of a plus h minus f of a over h. That's what we're doing. Way back at the beginning of the year, like one of the very first things I taught you was, if this is a function, and I said, what is f of 3? And you had to plug in 3. And what is f of 2 plus 7 or whatever? And then it had stuff like f of a. What did we do for like f of a of a function? Anybody remember? If I said evaluate this function at a, what was your answer? Yeah, it was just 2a plus 3. We just plugged in an a for every x. That was way back in chapter 1. All we did was plug in whatever I said to evaluate the function at, we plugged that in for every x in the function. Well, that's exactly what we're doing here. So to plug it into this formula, the 2 things you're going to need to find first are f of a and f of a plus h. You have to find what those are first. F of a is simple. You just substitute every x out for an a. That's f of a. A plus h is done the same way, except it can be a little bit more complicated. Got to get this thing fixed. You substitute out an x. Who here has Mr. Hop's German class?